So in this module, in this topic, control flow, what we are going to discuss is about how the intermediate representations are generated for the Boolean expressions. Okay, we have so far we have studied about the arithmetic expressions, how the three address code is generated for that, and so on. So in this topic, we'll be discussing about the control flow statements like if, else, while, and how Boolean expressions and the Boolean operators are used in this, and how the three address code is generated for this expressions. Okay. The first one, this Boolean expressions, they are usually used to alter the flow of control. So so what is altering the flow of control is that we know that when you have an if else statement or a simple if statement, so you will have an expression, and if that expression is true, then it will go to the true part. If not, then it will go to the next set of code, or it goes to the else part. So now, as you keep on executing the sequence of instructions, now this kind of Boolean expressions, when it comes, it will change the flow of control. Okay, so whether to continue in the same sequence or to skip this and go to the next part, this is decided by this Boolean expressions. So usually, this Boolean expressions, they are used as the conditional expressions, so that it alters the flow of control in the way in which we are executing the instructions. So, for example, if you have this simple if statement, if of e, yes, so the expression e must be true. When it is true, then it reaches the statement yes. Otherwise, it skips this statement yes and move on to the next part of the code. And the second one is Boolean expressions are used to compute the logical values. So as we know this, the Boolean values usually are represented with only this true or false values, and um, we will be using the logical operators or this Boolean operators to find out the true or false values. The Now this Boolean expressions, how it has to be used is determined by the syntactic context. So we, as we have seen, it can be used either to alter the flow of control, or it can be used to compute some logical values. So this can be specified using various ways, like you can use the inherited attributes, or you can use two different non-terminals, or you can even set a flag for the during the parsing. The thing what we have used here is using the inherited attributes, which we have already studied. So now you consider the Boolean expressions. So how these Boolean expressions are made up of? It is composed of this Boolean operators. So I hope you know what are the Boolean operators, right? So Boolean operators, we use this and, or, and not operators. So these are applied to the either the Boolean variables or the relational expressions. So when we use these Boolean expressions, which is made up of the Boolean operators, we will be getting the so we will be doing that mainly for altering the flow of control, or otherwise to compute the logical values. So here we have been given a grammar which involves the Boolean expressions. So B gives B or B, B and B, and so these are all logical or logical and, right, and B not B, and B within the bracket. And here you can see relational operator E. So of course this E represents the arithmetic expression, okay, and the relational operator here, it can be any one of these six comparison operators like less than or equal to, not equal to, all these things. So when how you can say that this is a boolean expression is that the output that it will give is going to be either a true or false value, right, a logical value it will compute. Because if you are going to compare any expression, for example, if a is a if A is greater than B, okay, or you may be comparing some other thing, A equal to B. So what would be the result if it is if it is greater than, then it will give you the result as true, or if it is not, and then it will give you the result as false. So the output that you are getting is a boolean value, a true or false value. So that is why this is also included here, and then simply a true or false value. So now this boolean expressions we can generate based on the requirement, or what we can say that unlike arithmetic expressions, this can be evaluated whichever is needed, okay. So it is not necessary the entire expression needs to be evaluated. So here I'll tell you what it is. The semantic definition of the programming language determines whether all parts of a Boolean expression must be evaluated or not. So what does that means? If I say B or B, okay, you have an expression on the left hand side of this operator and another expression on the right hand side. So as we know, the truth table of our operator is that even if any one of the input is true, the output would be true. Okay, so either the first input or the second input, even if one is true, the other is also true. So in that way, if you are evaluating the first expression, and if it is found to be true, then obviously the total result of this expression is going to be true, and it is not necessary that the second has to be evaluated. Similarly, if you are having and operator, okay, then here also if the first one is false, then obviously the entire thing is going to be false, because we know that only if both the inputs are true, your output will be true. So even if one is false, then the entire output will be false. So in that case, you need not evaluate this at all. Okay. So the compiler can optimize the evaluation of Boolean expressions by computing only enough of an expression to determine its value. So whichever part is needed to be evaluated, that alone can be decided by the compiler, and it can evaluate only that part. So now we have another thing called as short circuit code, which is otherwise called as jumping code. So what we are mentioning here is, so in the previous grammar we have seen that all the Boolean operators were used in those expressions. Now, what this short circuit code is that the Boolean operators can be converted or translated into jumping conditions, okay, or conditional jumps. So it means that here these operators need not be, we need not include the Boolean operators in the code. Okay. For example, let us take this particular statement, this Boolean expression. So what this Boolean expression says, if x is less than 100, okay, so let us assume that this is Boolean expression 1, or actually this is a relational expression, this arithmetic expression only with a relational operator. Okay, we can say that this is e1 e2, we having a relational operator. Now we have a, boolean operator. So this is one expression, boolean expression, and this is going to be compared with this thing. Okay, here we have an and operator. So either so now the first one is this, and the second expression is the whole thing we can take. So if this is, since we have an or operator, um, when you compute this or evaluate this, if this turns to be a true, okay, if this value turns to be results in a true value, then what does it mean? Since the first part is true, for the first input is true, it is not necessary to evaluate this second part at all. Okay, so when this is true, the entire if condition is true. So you can assume that this, since this is true, you can execute x is equal to 0, this particular statement. Suppose, okay, instead of true, if this is false, okay, if this is false, then what happens? You need to evaluate this second part. So while doing so, here we have an and operator. Okay, we have an and operator. So it means that we need to evaluate both the things, because only when both are true, you can say that. When both are true, this entire thing will become true. And so since this is false and this is true, the entire if condition would become true. Okay, so now it first evaluates x is greater than 200, and if it founds to be false, okay, if it founds to be false, then it is not necessary this part has to be evaluated. Okay, it is not necessary that this has to be evaluated. So you can directly say that this entire if condition is false, because anyway already we have found this is false, and now in this and operator, when the first input is false, the total thing will be false. So it means that whatever comes after this, sorry for the interruption. So now, as we have seen, this is false and this too is false. So this statement is not going to be executed. Then it should be followed by the remaining statements, whatever comes after that. So suppose if this is true, then you have to evaluate this also. And if this finds to be false, then again the entire expression would be false, and you will be landing up in um, evaluating the or executing the statement after this. Okay, so now this is your condition. Now how this can be expressed as a code, a short circuit code where no boolean operators were used. Okay, if you look into this code, there is no boolean operator used here. So what we have done, if x is less than 100, okay, if this part is true, then automatically the entire if condition is true. So directly you can go on to execute this x equal to 0. So x equal to 0 is present in label L2. So if x is less than 100, go to L2. So if it is false, okay, if it is going to be false, then we need to execute this. And if this condition, if this x greater than 100, 200 is also equal to false, okay, then again the entire thing becomes false. So this is also false and this is also false. So you will be landing up in the next statement coming after this. So if false of x less greater than 200, go to L1. So L1 is the whatever the statements that comes after this. Okay, and suppose if it is true, then again you need to evaluate this part. So now again, if this is true, then it will be executing this, or if it is false. Okay, if this is false, if false of x, if false of x not equal to y, if this part is false, then again we need to, we can assume that the entire thing is, if condition is false, and it goes to the label L1, go to L1. Suppose if this is true, then automatically it will come to the next line to execute x is equal to 0. Okay, so the short circuit code, it helps to translate the code boolean expressions having the boolean operators into a code without any boolean operators. Okay. The next one is, um, so now we'll see how the Boolean expressions can be translated into the three address code in the context of statements. Okay. So first we will see what it is, and then we will go and see into the syntax directed definition. So there's a poll coming up. The poll is given in your thing. Give the answers. So only one is alive in the class. Only two. So this polling I will take for the attendance. Okay, I'm going to end the poll. You want to answer, quickly answer. Okay, we'll continue. Now, we have a set of statements. Okay, now we will see all these are all if statement, simple if statement, and if else statement, and then while statement. So we have these statements, and we will see how this Boolean expressions are going to be translated into three address code. Now we are going to use the labels with the attributes true and false, and so both of these we have the variables b, okay, which represents the Boolean expression, and the statement s1. So code is the attribute associated with that, b dot code and s1 dot code as well as s dot code. So here, when the Boolean expression is evaluated, either it can be true or it can be false. So if it is true, it moves to the set of statements that comes under the label b dot true, and if it is false, then it moves to this set of code. So, since the first one is a simple if statement, okay, it is a simple if statement. So, if it is true, it goes to this part. Otherwise, directly it goes here. Okay, and in the case of if else, in the case of if else, if it is true, it goes to the true label. So what it is, here you will have a set of three address instructions. So the first three address and instruction, this label will be pointing to, then followed by all other three address instructions related to this S1. And so if it is true, it goes here. After completing this part, then it has to skip this. It it need not execute this else part. So it has to go to the label s dot next. Okay, what follows this s2 dot code. So go to of s2 s dot next. So this is your if else statement. Suppose if it is false, okay, if this expression is false, then it goes to this label and executes s dot code, and then actually it continues. And also we have a while statement. So we know in while statement, we first time you evaluate that expression. If it is true, you execute the statements, and so this will be executed until this condition becomes false. So again and again, this condition will be checked, and until it is true, this will be this set of code will be keep on executing again and again. Okay, when it becomes false, it comes out of the next statement. It comes out of this while loop and it goes to the next statement. So that is why we have another label called begin. Okay, so it checks this expression. If it is true, it executes this s1 dot code. If this part is executed, and then again it goes to begin. That is, again it will again it checks the condition. So until it is true, this part will keep on working. Okay, when it becomes false, then it comes to the b dot false label and continue to execute. The next one is syntax character definition for the flow of control statements. So here we have this P represents the program, which consists of the some statements, and we have a set of statements. So whatever we have seen, simple if statement, if else statement, while statement, and this is simply an assignment statement. So now we can see here So for the program, we have the attributes code, and so as we have seen, for every code, it is going to generate either a true label or a false label. Okay. So this label, so what we have seen here in the previous thing. Okay. So here we are generating this label, right? So this label, it is going to be created using this function new label of. So new label of creates a new label each time it is called. So we have the statement yes. So yes dot next is a inherited attribute, and it this new label creates a new label, either a true label or a false label every time. Okay, depending on the name that we can give it. And so this code will be the code that we are executed for this statement, and along with that, this label of, okay, what it mentions is label of L attaches the label L. Okay, so you are creating a label. For example, we are creating a label b dot true. Okay, so this label, it is going to be attached to the next three address instruction to be generated. So we can see here, so in the previous case, so this b dot true, this label is created using the function new label of, and then that is attached to the next three address instruction. So this s1 dot code will have a set of three address instructions. Okay, so the first instruction, second instruction, third, and so on. So it will be attached to this next the first three address instruction to from which you are going to you are going to execute it. Okay, so if you take the first simple if else statement, here we have, we'll see with the example. So let us take this one. Okay, simple if statement. So now here you have the SDD. So first what we need to do, we need to create a, since this is a simple if statement, when this condition is true, it goes to this s1 dot code. So first we need to create a new label for this true condition. So let us name that label as b dot true. If the condition is true, then it goes to s1. So this s1, as we have seen previously, this s dot code has to be labeled with b dot true. So we are first creating the label b dot true is equal to new label of, and then again we are creating a label called b dot false. So what would be b dot false after this? So this is s1, right? So if it is true, it goes to s1 dot code. So after this s1, uh, what comes after this would be s1 dot next. Okay, what comes after s1, and now when this becomes false, okay, initially you are evaluating the expression b dot code. So if this becomes false, okay, then automatically it goes to it would be also going to s1 dot next. Okay, if it is false, it skips this part, because this is the true part. It will skip this and it goes to s1 dot next. So that is what the that is also equal to s dot next, because we are actually evaluating the statement yes. Okay, so what is the code for s dot code is equal to, first we need to evaluate b, and so it may result in either you will be getting the condition is true, then it will give you the label b dot true, label of b dot true. You go evaluate, execute this part, and then followed by, so you will be getting so it goes to this position. Okay, label of b dot true, and then followed by executing this s1 dot code. The next one is flow of control statements for the if else statement. Okay, so we have already seen how this works. Now you can see the SDD, syntax directed definition. So again, since this is if else part, definitely there will be a true part and also there will be a false part. So if this condition is true, it goes to S1, else it goes to S2. So we create two labels b dot true and b dot false. And so what is S1 dot next? Okay, so what comes after this S1 dot code? S1 dot next is equal to so here we are so when this is true, okay, when the code is true, it goes to this label and executes S1 dot code, and it moves, it skips this part and it moves directly. So that's why it is go to S dot next. It goes here. Okay, and if the code is false, then automatically it comes to the label b dot false. Okay, it comes here when this when it is false, it comes here. So now after executing this part, what comes next, that is going to be represented as s2 dot next. Okay, so whether it is s1 dot next or s2 dot next, both are equal to this label s dot next. Okay, if it is true part, it will execute this s1 dot code, and what comes next would be this s dot next. And if it is going to be false, it executes this code, and what comes next would be it is equal to s dot next. Okay, and the code will the code for this statement would be you have first you evaluate b dot code, and you will get the label b dot true. Then you go here, so execute s1 dot code, then generate go to of s dot next, and if it is suppose false, you have label false and you execute s2 dot code. And then we have the while statement. So how to write the SDD for while statement? So now so what we are actually looking at, we are finding out the three address code for the all these um, jump statements. Okay, all these sorry, control flow statements. So now again here also, as we have seen, we have a begin label, the true label as well as a false label. So we create begin label and true label. So once this code is evaluated to true, you execute this, and again you come back to begin. So again you execute this when the code is true. So sorry, when this code is true, you execute s1 dot code, again you go to begin, again you evaluate it. If it is true, again you evaluate s1 dot code, again you go here. Okay, so this loop will go on until this becomes false. When it becomes false, you come out of the loop and you start executing the statements here in this label. Okay, so see here, b dot false is equal to, so if it is false, then what is the meaning, what comes after this s1 dot code, whatever that is the s dot next. Okay, so the code will be you first have the label of begin. So because we are having first, we have a begin label, that is where we first initiate. So this is what we are going to first execute. So you start with the begin label, then you evaluate it. When you get is true, you execute s1 dot code, then again you go to begin. Okay, so this loop will continue forever. So this is how we write the SDD for converting the for translating the Boolean expressions into the three address code. So this the same thing what we have seen so far. Now this is for specifically for the Boolean operators it is given. Okay, so this is also similar to that we have got for so for B1 or B2. Okay, here even if it is one is true, then the entire expression would be true. So you have the labels. So if b1 is true, okay, b1 dot true is equal to b dot true. If this is true, then automatically this will also be true. Okay, and if b1 is false, then you have to create a new label and go to b2, and you have to evaluate it. If b2 is true, then this will become true. If B2 also will be false, then this will become false. Okay. So if this is true, this also will become true. If this is false, then you go to evaluate B2. If this is true, then this is also true. If this is false, then B will also be false. Okay. And similarly here also. Here the thing is both should be true. So first you initially create a new label because we need to evaluate we even if it is true, we need to evaluate this also. Okay, so if so b1 dot true is equal to new label, and b1 dot false, if it is false, then automatically this will also be false. If this is false, this will also be false, because one is false, then automatically this whole expression becomes false. And if this is true, then again you need to execute this also. So if b2 is also true, then b also becomes true. Okay, then but if this is false, then this becomes false. Just you have you the same concept you have already know. Okay, so when both are true, the result will also be true. When one is false, the result will also be false. So here it is simply not of. So if this is true, then the other one is false. Okay, if this is false, the other one is true. So this we have already seen in the previous thing itself, generate of. If this e1 dot e1 dot address relational operator e2, we are finding if if both are true, if based on the relational operator, whatever it is, less than, greater than, less than, equal to, whatever it is, if this condition becomes true, then it would be we go to the label b dot true. Otherwise go to the false part. Okay, so whether it is going to the true part or to the false part, it is based on this result. So this is simply directly true and false available, so go to the true part or go to the false part. So this is the flow of control statements using the Boolean expressions, and we have seen how what the Boolean expressions are used for, and how these Boolean expressions can be translated into the three address code using the SDD. Okay, so give your did you understand the concept? Give your reply in the chat box. Only one present in the class. There is only 4 minutes left, so I'll give you the quiz in the class next class. Okay, give your attendance. James,
Then, ma'am.
Kiran, Ayan, Anselin,
Present, ma'am.
Sanath Chandran,
Present, ma'am.
Chris Thomas, Ruben, Alan Babu, Rubab Daniel,
Present, ma'am.
Albi Shinoj.
Present, ma'am. Present, ma'am.
Who has said present now?
Ma'am, I'll be Sinoj.
Okay. Daniel Prem,
Physical, ma'am.
have they sent the letter?
Yes, ma'am.
Okay, post it in WhatsApp to me. Rainius,
Present, ma'am.
Sharon,
Yes, ma'am.
Nivin Abraham,
Yes, ma'am.
Justin, Justin, Josia,
Yes, ma'am. Present, ma'am. Present, ma'am.
Josia,
Yes, ma'am.
Charan,
Present, ma'am.
Jaswin,
Yes, ma'am. Present.
Angel,
Present, ma'am.
Prithvi,
Present, ma'am.
Jaden,
Present, ma'am.
Carolyn,
Yes, ma'am.
Angel Henry,
Present, ma'am.
Kushmita,
Yes, ma'am.
Ratnakumar,
Yes, ma'am.
Central Arasan,
Present, ma'am.
Dalu Vijay,
Yes, ma'am.
Chanay Arjun,
Yes, ma'am.
Rohan Paul,
Present, ma'am.
Sudan,
Yes, ma'am.
Abhinesh,
Yes, ma'am.
Crazy,
Yes, ma'am.
Jabba Weslin,
Yes, ma'am.
Chris, Chris Jaren,
Ma'am, he has physical. He had sent you, ma'am.
physical, okay. Delicia,
Yes, ma'am.
Samu Idayan,
Yes, ma'am.
Linus,
Present, ma'am.
John Blessing,
Present, ma'am.
Delin,
Yes, ma'am.
Derry Jaswin,
Yes, ma'am.
Goga Sujit,
Yes, ma'am.
Esther Joyce,
Yes, ma'am.
Jerusha,
Yes, ma'am.
Vignesh, Vignesh, Leo Joseph,
Yes, ma'am.
Sasank,
Yes, ma'am.
Yeah.
Narisati Sasank, who has given the attendance now?
Ma'am, Shashank Cyril Raj.
No, I called Narisati Sasank.
Absent,
Janet,
ma'am.
Janet Sherin,
Yes, ma'am.
Rajat,
Present, ma'am.
Jim Jerome,
Present, ma'am.
Samson,
Present, ma'am.
Yakin Jinsen,
Present, ma'am.
Abhishek,
Present, ma'am.
Nirmal,
Present, ma'am.
Sandra,
Yes, ma'am.
Sarvesh,
Yes, ma'am.
Efalina,
Present, ma'am.
Efalina, Anisha,
Present, ma'am.
Alex,
Present, ma'am.
Shashank Cyril Raj,
Yes, ma'am.
Talha.
Present, ma'am.
Okay, thank you, students. You can leave the class.